Okay, so today we are going to be covering two lessons, 5.2 and 5.3. 5.2 is a pretty quick lesson, and so it'll go nicely with 5.2 and 5.3. So the homework is a combined homework 5.2/5.3. It's not two separate assignments, okay? Okay, so let's talk about corresponding parts. Okay, so corresponding parts are parts of two objects that are in the same, and you might need more space than the line gives you, relative position of these objects. Parts of two objects that are in the same relative position of these objects. Parts of two objects that are in the same relative position of these objects. So as you can see below that, we have an image of two different triangles, and we have lots of different markings on those triangles. Okay, can someone remind me what those different markings would be referring to? Yes.
The two with the same marking.
Good. So anything with the same marking would be congruent. So if we're looking at our options here for corresponding angles versus corresponding sides, it tells us what things are congruent to each other. Okay. On the image, it also told us that. So here we have angle A is congruent to angle D. Okay, what marking on the image tells me that? The what? Yeah, so when you have angles, it's kind of like an arc versus the sides. For example, AB is congruent to DE. Those both have two marks. So everything is going to have a separate marking so you don't think that everything is congruent to itself. Okay, so in reality, what we're looking at is matching parts. Okay, so we want to make sure that we have matching parts. Okay, so then if that is true, if we're looking at our triangle, okay, they're not facing the same direction, right? So it's kind of like one is facing this way, and then the other one is like it flipped over because A and D are congruent, B and E, and C and F. So it's kind of like it's a mirrored image. Does everyone see that? So it's still the same triangle, it's just a mirrored image of it. So on these shapes, if it tells you that they are looking for congruent statements, you just need to make sure you have the matching part. So don't just say, oh, well, C is in the left corner and D is in the left corner, so those are congruent. Okay, so you have to make sure that you're looking at the specific parts. Okay, so when all corresponding parts are congruent, then the triangles are congruent as well. So if you can prove that all corresponding parts are congruent, then the triangles are also congruent. So if all three angles and all three sides are congruent, then you have congruent triangles. So we talked about matching parts, making sure that your letters are corresponding. This is most significant when you're talking about side lengths, okay? Because with side lengths, it's not just a single letter, you have to have at least two letters. So for example, on the corresponding sides, we have A, B, and DE. You'll see that they started with the matching parts. So A and D are congruent, and they go to B and E. So you want to make sure things are in order, okay? So in the past, I've said, oh, order doesn't necessarily matter in most cases. When you're talking about corresponding sides, angles, or statements, the order does matter. So you want to make sure you have the matching parts, okay? So in a congruent statement, the order of the letters matter, okay? Just like what I said, the orders have to matter. Order is important, okay? Circle it, underline it, highlight it. The order of the letters matter, okay? And so therefore they must correspond with each other. We can't just put random letters. They have to be matching, okay? Because if I'm saying that they're congruent or corresponding, they have to be the same letter that we want. So for example, if I was to create a congruent statement for these triangles, and I said triangle ACB is congruent, how would I have to name the other triangle for it to be correct and corresponding? So look at your image. So ACB, how would I name the other triangle so that the parts are in the same order? Give everyone a second to think about it, look at it. All right, someone have an answer? Yeah. DFE, good. With the triangle in front, that would be correct. Okay, now below it, what I want you to do is to write at least 2 different congruent statements for the above triangles. So I could go in a different order. So I said ACB on this one. I could have done ABC. What would have been congruent if I did ABC? Or what if I started with DFE on the other one? So make 2 other congruent statements. Remember, order matters. You can go in any order you want. All right, tell your neighbor what you came up with. Or work with your neighbor to come up with something. There'll be a lot of blank pages. Okay, let's see what we have. So there's lots of options you could have had. So what is one option someone came up with? Yep. Okay, CAB is congruent to triangle FDE. That's correct. That one works. It's always fun when you can spell words. Yep.
I have another one that spells the word FED is congruent to CBA.
FED is congruent to CBA.
The feds are coming for it.
Okay, so those are 2 options you could have had. Now remember, there's lots of different ways you could have named these angles. So what you wrote may not necessarily be wrong. I just wrote down 2 options. Okay, there's tons of ways you can rearrange the orders. Okay, not unlimited ways, but there's definitely a ton of ways. Okay, any questions on how to name those? All right, good. I did see a couple of people with just one part of it. Make sure if you're doing a congruent statement, you have to say Something is congruent to something else. So whether it's angles or sides or triangles or shapes, you have to have two parts. All right, let's practice some problems. So in exercise 1 and 2, identify all parts of congruent corresponding parts, then write another congruent statement for the polygons. Oh. All right, so looking at our triangles, interpret where the lines are, interpret where the information is. What would be the congruent angle to angle P? Yep, angle S, good. Okay, what about angle Q? Angle T, great job. And so last but not least, but also confirmed, we have angle U. Okay, the angles are the easy ones because they kind of give it to us very clearly. However, with the sides, it's a little bit trickier, but not incredibly trickier. You just have to pay attention a little bit more on order. So on this one, we have PQ. Oh. PQ. So if we're going from P to Q, what would be the corresponding side on the other side? Yep. ST. I kind of already said the answer on accident, but ST. Now, when you write your answer, make sure these are capital letters and make sure you put a bar above it to represent that that's a side. Okay. All right, go ahead and try the other two. QR and PR. What are the sides that are congruent to those two? All right, share with someone near you what you got for those two blanks. Okay, now remember, order does matter, so you should have matching answers. So QR would go with, as a class, what would it be? TU, good. And PR, SU, good job. Okay, now it also said in the instruction we were supposed to write another congruent statement for the polygon. Okay, I forgot to leave a blank for it, so we're gonna just make a little line there, okay? And I want you to make a congruent statement for this triangle. So we already have this one up here, which says PQR is congruent to STU. So do another practice of creating a congruent statement. Okay, check with someone near you what you wrote for that one. See if we improved from the last time. Okay, what do we think is an option for this question, or this answer, I should say? Yep.
QRP is congruent to TUS.
Or QRP is congruent to TUS. Is that what you said?
Yes.
Okay. Yep, that one works. Okay, and again, there's unlimited option, well, not unlimited. There is quite a bit of options you could have used. So again, your answer could still be right, even if it's not the one we just wrote down. Okay. If you're concerned about it, I'm happy to come around and check a couple if you want, but just know like on an assignment, if it was open-ended, it just means there's a lot of options that it could be. Okay. All right, number 2. So we're not going to do number 2 full out just because you kind of are getting the concept of it. But I just want you to practice a couple of them since it's not a triangle, it's a quadrilateral. Okay, what angle is congruent to angle A? Angle E, good. And what about side AB? EF, good. Okay, and so this is really just to show you that the same concept can be applied with any shape. Okay, it doesn't have to be a triangle. Okay, so there's multiple other congruent sides, congruent angles, all that jazz. Okay. Give a second for anyone still writing anything. You can turn your page if you're ready. All right, I'm going to be grabbing a couple highlighters. If you want to grab some, you can do so. Okay, question 3 and 4 are going to wrap up our topic on 5.2. And it's the same concept from before. We're just going to be solving with a bit of algebra in there. Okay. So in exercise 3 and 4, we're going to find the values of X and Y. And what we're told is triangle XYZ is congruent to triangle RST. So really the biggest thing here is focusing on what is common. Okay. So what do we always know about triangles or angles when we have them in order of 3 letters? What's important about the 3 letters when we name something? For example, if I name an angle, what's important about that middle letter? Yep.
It always has to be the vertex.
It always has to be the vertex. Okay. So thinking about in relationship to a triangle, if I'm labeling something X, Y, Z, and the order has to matter, okay, we know that X is always going to be R, Y is going to be S, and Z is going to be T. So thinking about it as that middle letter situation, we know that we have angle Y right here. That's going to match with angle S based on the order that they're written, okay? And that's true for everything else, okay? So X is congruent with R. And Z and T, okay? And this is helpful just in the sense of when it doesn't give you the angle measurements of being congruent, it's easier to visualize, okay, these 2 are congruent. And so that the shapes don't kind of play anything on your eyes and you can keep track of everything. So with that being said, we have some bits of information, okay? We have 15 centimeters, we have a 3y plus 9 centimeters, 30 degrees, and 2x minus 20 degrees. Since we color coded and labeled our picture, it'll be easier to see what parts are matching because it tells us the 2 triangles are congruent. So if the triangles are congruent, what do we know about the sides and angles? If we know the triangles are congruent, so if the triangles are congruent, we then know all the angles are congruent and all the sides are congruent. And that's really just an application of this statement right here. When all corresponding parts are congruent, the triangles are congruent. So if the triangles are congruent, that means all corresponding parts are congruent, okay? So in that case, what could I set up to solve for X? And when I say X, I mean the variable X, not the angle X. What statement could I set up to solve for the variable x? 15? No? Are 15x and 2x minus 20 the same type of shape or image? So what's matching? What would correspond with each other? Think about the colors we just did. So 2x minus 20 degrees. What am I going to do with that to solve for x? Use the 30. Good, because y and s are congruent. That means these two measurements would have to be congruent. Does that make sense? So I'm going to set up my equation. So I have 2x minus 20 equals 30. And again, because these parts are congruent, that means my statements are congruent. Go ahead and solve for x. Right. What does x equal in this scenario? 25. Good. I add the 20 over. I get 2x equals 50 divided by 2 and x equals 25. Good. Okay. What are we going to do about the y variable? The issue with the y variable is, do we have a matching part with what we're given? Do we have something in the pink to purple range on this triangle? All we have is this little marking. What do those markings mean? That it's congruent to the other one. Good. What does it mean when there's two of those on a triangle? What type of triangle do we have here? What does it mean when you have two congruent parts on a triangle? What's that called? It's isosceles. Good. So because of these markings, we know we have isosceles triangles. Okay. And because of those markings, we have an isosceles triangle. What do I now know about the other two side lengths that don't actually have information? What do I know about those two? What could I mark in there? So if they're congruent markings, and we know it's isosceles, meaning there's two sides that are congruent to each other, what could I put in the spaces for the markings? Jackie, what can I put there? If this mark means congruent, what can I label this side as? Good, 15 centimeters. Is that the same true for the other triangle? Yes. Alyssa, did you have a question or answer? Sure. Okay, so therefore, what would I do to solve for y? Since we know that now. How do we solve for y now that we know that? Correct. 3y plus 9 equals 15. Go ahead and solve for y. Bless you. All right, what does y end up equaling? 2. Good. Subtract the 9, you get 6. Divide by 3 and y equals 2. That is correct. All right, number 4, I want you to try it on your own. So I'm gonna give you some time to try that on your own. All right, so while looking at what we have here, okay, we have to go with x first, okay, because that's gonna be the key to this. In order to solve for x, or sorry, in order to solve for y, we have to solve for x first. So let's look at our matching part. So if we have A, B, C, D, E, F, G, H, we know A and E are corresponding. So A is corresponding with E. And then from here, C would then correspond with G. C would correspond with G. So if you don't start by identifying the matching parts, then you're going to set up the problem wrong. So that is an important step. From here, we want to set up our equation. Now, again, I did say you had to solve for x first. Reason being is when you solve for y, there's also an x in there. So if you don't know what x is, you can't solve. So we'll start with x first. So 60 plus 8x equals 108. Oop, not 180, 108. So when I subtract, I get 8x equals 48, divide, and x equals 6. Now that I know x equals 6, on the other equation, I'm going to have 8y minus 3 times 6 equals 62. So I'm replacing x with the value that we just found. Reset. So again, to clarify, originally it was 8y minus 3x equals 62, but I'm going to replace the x with 6 from what we just found. Okay, if you haven't solved for y, go ahead and do that now. Okay, so when solving this, we would have 8y minus 18 equals 62. Add the 18 over, and you should get y equals 10. All right, any questions or concerns regarding questions 3 or 4? A couple people still writing, so I'll give you a second there. Okay, so, and that is it for 5-2. Okay, 5-2, like I said, is a pretty quick lesson. The biggest things of 5-2 is that you need to make sure you're talking about matching or corresponding parts. Okay, if you mess up the parts, similar on number 4, if you're like completely skipping that step in your brain, you might set up the problem wrong. So you want to make sure that you have the matching parts identified, whether you use colors or circles or squares or whatever you want to do to help make sure that you have the correct corresponding and matching parts before solving. Because 9 times out of 10, well, I shouldn't say 9 times out of 10, there's always someone that will immediately just set it equal to whatever's inside the image itself. Okay, so you want to make sure you have matching parts in order to solve. Okay, that's really the biggest key in 5.2. Okay, now matching parts is also important as we go forward when we're naming things. But mathematically, it's very important that you have those matching parts in order to solve the problem correctly. Okay. All right, any questions or concerns about 5.2? All right, let's talk about 5.3 then. All right, 5.3 is when we're going to start talking about proving triangle congruency. So we've figured out how to solve for parts of the triangle or angles, and we've learned how to name or corresponding parts. Now we're going to talk about how we can prove things are congruent. Okay, so theorem 5.5 states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, let's break that down just a little bit more. So if AB is congruent with DE, okay, so let's use some colors to help us here. So we have AB is congruent to D. So just to add a little color, we already have markings on there. If angle A is congruent to angle D, angle A, angle D, and if AC is congruent to DF, AC and DF. If those are all true, then we know the triangles are congruent. Okay, but the question, hopefully, that you're thinking or possibly thinking is, well, why can I name this with only 3 parts versus all the parts? Well, what we had said in 5.2 is that if all congruent or matching or corresponding parts are congruent, then the triangles are congruent. What we're going to learn in the next few lessons is that there are some situations, shorthand version like side angle side or SAS, or my favorite version, Sumner Academy Sabres, SAS, but side angle side, there's going to be other shorthand versions to say that if you can prove at least these 3 things in this order, then you can also say the triangle's congruent. So I don't have to go through and figure out the rest of the information. As long as I have a side, an angle, and a side in the order that we're speaking about, then I can prove congruent triangles. So in the definition, it talks about an included angle. Based on the definition, based on the picture, what can you interpret that included angle means? If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of that triangle, they're congruent. What does included mean?
Basically the angle formed by the 2 lines meeting.
Good job, yeah. The angle formed between the 2 sides of the triangle. So by definition, D and E are not included angles, okay? Because they're not being formed by the 2 sides that we are referring to. Okay, does that make sense? The included angle is essentially the angle in between the 2 sides that you're referring to, okay? So it largely depends on what side you're referring to. I wouldn't be able to just look at a triangle and say, oh, angle A is the included triangle. I have to know what sides we're referring to know what angle would be included. Okay. Okay, what about the second thing? So describe in your own words which sides and angle must be congruent to use the SAS theorem. Okay, so how could we describe using our own words how we would determine which sides and angles must be congruent to use the SAS theorem? So essentially shortening down our definition into something a little bit easier to comprehend or remember. What do we think? What are keywords in that? So do I need to have one side, two side, three? Yeah.
Well, you have to have two adjacent sides specifically. They can't just be out in the open and say, oh, those form an angle.
True. They have to be connecting sides. Anything else from anyone else? Okay, so doesn't really make sense for me to explain it. So why don't you write down something that makes sense to you to simplify the definition? Describe in your own words. Your own words, not my words. You describe it. Write down a summary of what that would be. Shorthanded, symbols, whatever you want. Write something down. Okay, so like I said, this can be any way that makes sense to you in your own words. The biggest things are you have two sides with an included angle that are congruent to corresponding parts on the other triangle. Okay, now this is specific to triangles, just to clarify. Okay. All right, so hopefully you wrote something that helps you to clarify the theorem, because obviously with this, a lot of times it can be overwhelming. So if you shorten it down for yourself, that's good. All right, so let's look at some examples. Name the included angle between the pair of sides given. Okay, name the included angle between the sides or the pair of sides given. So we have JK and LK. So we have JK and LK. How can I name that included angle? Yep.
Angle JKL.
Angle JKL, yeah. Could I have just said angle K? It's a great question. Could I have just said angle K?
I believe so, because that's not a point. There's no real indication of a point there.
So anytime there's a letter there, it's indicating that there's a intersection point. Okay. So it's a good thought process, but why can this be just K? Yep. Great job. That was a great definition. Okay. So he said, I can't use K because I wouldn't really know which part I'm referring to. Am I referring to the left side, the right side, the whole thing? Okay, so remember the rule of thumb is you can name an angle by one letter only if it's the only angle there. So for example, could I name angle J by itself? Could I say angle J just by itself?
Yeah.
Yeah, there's just one letter there, right? Is there a second angle that would be forming from that? No. Could I say angle P by itself? Could I say angle L by itself?
No.
No, because there's three different angles coming just from that one spot. Does that make sense? Okay, go ahead and do B then. KP and LP. What's the included angle for KP and LP? What's the included angle between KP and LP? All right, tell someone near you what you got. All right, what is my included angle? Yep,
Angle B.
angle P, okay. I could use one letter. Could I use multiple letters? Yeah, so what's a way I could use multiple letters? What's, yep. LPK. Okay, I also could have said angle KPL. Okay, so just know that there again are multiple options you could have used. In this case, you could have used one letter. You could not have used one letter here. Yeah. Yes, correct. Good job. You also could have said LKJ on this one. Okay. Biggest thing here is you, on these two, you can't use one letter when there is more than one angle. Jangle, 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 jangle. Sometimes I'm just talking faster than my brain, and they're just words combine.
The problem with being faster than light is faster than
True. All right, any questions about example 1 for 5.3? Give a second for anyone to write down what they need to write down before we move on to the next page. Lots of emails coming through. It's, I mean, they're normally emails from teachers that are on their plan time, or administrators or nurses or district people. I could have emails from a lot of people, parents, I could, whatever. I don't have a dog, so that'd be a weird one. I got an email from my dog. Even weirder if it was my childhood dog, that's not with us anymore. All right. All right, let's look on the back side here. Okay, so 5.3 continued. This question is a little bit more involved. So this one says, decide whether enough information is given to prove that triangle ABD is congruent to CDB using the SAS congruence theorem. All right, so what we want to see is, do we have two sides with an included angle and corresponding parts on both triangles? Okay, so again, the biggest thing here is making sure you have matching information. Okay, so with A, it would be matching with C. And then B and D. Oh, wait, and then D and B. They use the same letters back and forth, okay? So this is where these things can get a little confusing, because technically they're using the same letters, but in a different order, okay? And that is perfectly possible, but yet it can be very confusing when you see it for the first time. Okay, so based on the way that these triangles are set up together, the two letters that are essentially being used twice is because you can order it in a different way. Okay, so I could start off here and go left, right, etc. So there's going to be a specific order to what we're looking at. So A, B, D. So I'm going from A down and across. And then I have C, D, B. Okay, so they go up on the corners, go to the matching parts, and then go across. Okay? The question is, do I have enough bits of information? Okay, so I know that AD is congruent with CB. Okay, we have those matching parts, right? What is something else on here that's congruent but not marked? What is something else on here that I could say is congruent but not marked? Yeah.
I have no idea that's like how to word it, but it's the line like between the two.
Correct. So can I say that this line is congruent to itself? Yeah, it's sitting on top of itself, so therefore it is itself.
I could
Okay.
just say segment DB.
Yes. Segment BD or DB is congruent to segment BD or DB. Okay. Because it's essentially the same line and it's on top of itself, it has to be congruent to itself. Okay. If I'm using it two different ways, it's congruent to itself. The question is, I have two sides and two angles, or sorry, let me clarify. I have two sets of sides congruent, and I have one set of angles congruent. But are they in the order of SAS? That's the question. So I go from side, side, and angle, or angle, side, side. How do I label it? Okay, so again, that order matters. So let's look at ABD. Okay, so if we're going from A to B, is there anything we know yet? No, but from B to D, we have that angle. So we have angle, and we have a side and a side. So is it in the SAS? Is the angle included between the two sides? Is the angle in between the two congruent sides? Look at the picture. Is the angle, the included angle, in between the two sets of sides? So is it side, angle, side? No, it's not. In order for it to be included, it would have to be in between the two sides. This angle is on the other side, so it's not included. So no. Angle is not included.
Well, we know CD is 90 units long, AB is 9.1.
It's more the angle placement. So remember, if it's SAS, it has to go side, angle, side. In this picture, the angle isn't between the two sides that are congruent. So unless it's in that specific order, we can't prove it by this order.
No, I'm just saying that we don't know that CD and AB are congruent. For all we know, AB is 0.1 units longer.
Yes, so we can't assume anything unless it's given to us, we can't assume it. Okay, let's look at 3. So we're asking the same question, basically new letters. Decide whether enough information is given to prove that SPQ is congruent to TPQ. So looking at the image, do we have enough information to identify SAS? Bless you. Bless you.
What's our allergies today?
Okay, is there anything on this image that is congruent that's not marked? What? The line between what letters are those? Just need 2 letters for a side. So what are the 2 letters? You just said 1 extra letter. You only need 2 of them. Yeah. Okay, so student said the two lines together, or the line in the middle that is matching together, so PQ, is that congruent? Yes, it is. Okay. Remember, anytime you have two lines on top of each other or the same line, they're congruent to itself. Okay, so with that in mind, do I have enough information to prove SAS, side, angle, side? Do I have a side, then an angle, then a side on matching parts of the triangle? Yes. So we're starting at S and T. So from S, T, or sorry, from S or T going to P, are those sides congruent? Yes. Then do we have a matching angle at P? Yes. Then do we have from P to Q congruent? Yes. So we have side, angle, side. So congruent side. We have congruent angles. And another side. Side angle side. Okay, last two things we're gonna do are these two proofs, okay? Let's refresh our memories about proofs. So what is the first thing we should always start with when we have a proof? Yeah. The statement you're given, good. So my first statement is gonna be BC is congruent to DA. And BC is, what does that image mean? What does that little icon mean? Parallel, good. To AD. Parallel. Okay, and what is my reason for my given statement? I heard someone say it very quietly. What is it? Given, yep. All right, now let's look at what we are given and let's label some things, okay? Once you kind of get the first thing out of the way, you can label it. So BC is congruent to DA. Okay, so we have BC and DA. Then we have BC is parallel to AD. What helps us out when we have parallel lines? What can we prove? Yep.
That arrow.
Did you say, I didn't know if you were gonna say something after the arrow. Just the
no,
arrows.
The question rendered in my mind as what tells us it's parallel.
And I asked a different question, yeah, okay. So the first question I could ask is what tells us those are parallel? Other than it telling us in the given, those little arrows are what tell us that they're parallel. Now with parallel lines, what can I prove from the last unit that we learned? What can we prove when we have parallel lines? We can prove something's the same, right? We can prove angles, okay? Remember alternate interior, alternate exterior, corresponding, same side. Those all happen because of parallel lines. Yes, Christine.
Lines connecting between the two would be congruent then. Because they don't, the two parallel lines don't spread out any. This one is longer than this one.
That's correct. So let's first talk about the angle real quick before we get off to that part. Okay, so if we have parallel lines, this is parallel to this, okay, what angles could I say are congruent to each other then? Based on alternate interior, alternate exterior, any of those. So let me make the image simpler. So we have this line on top, and we have this line on bottom, and we have the line in the middle. Okay. What's the line called when it cuts through two parallel lines? What's that line called? Starts with a T. Transversal, good. So where would I have angles on here that would be congruent? based on this image. Where could I have congruent angles if these are parallel? And you act like AC is a transversal. Evelyn? So think about it in the fact that you have to use 3 letters for an angle. So I appreciate that you. So I'm trying to make the image easier by just showing this part versus the connecting lines, because I feel like sometimes the connecting lines confuse us. Yep. BCA, good. What would that go with? So you said BCA. Okay, so what's the matching part with B? Anyone can answer that. What letter matches with B? Yeah. Yeah.
Oh, angle CAD.
Nope. So again, we're trying to picture parallel lines. So if this angle appears, what angle would go with this one in between parallel lines? Which one would match it, Jason? Not ABC. Nope. A what? No. Yep. DAC, yeah. DAC, this angle down here. This is my transversal. I apologize if you said that. I apologize. If it was CAD or DAC, both would have worked. I apologize. I just misheard. I thought you said B. I thought you said B. So B and D are so hard. Okay, so yes. So what does that make those angles then if those two are congruent? What types of angle based on what we learned in the last unit? Yep.
Alternate interior.
Alternate interior, good. So because we know alternate interior angles can be congruent with parallel lines, then that's what we can say. So let's refresh our memory on what order we said. So on the first one, we said BCA. That's correct. Remember, the order has to be so what would be the order of the other one? But it has to be in the correct order. So if B and D are matching, DAC. So to clarify, Christine, the angle that you said was correct, but the order you said it was wrong. Okay, remember matching parts. So if B matches with D, that's why it has to go that way. Okay, and we said that was alternate interior angles. Okay, alternate interior angles theorem. All right, so now we have a set of sides and we have a set of angles. We just need one more set of sides to prove it. Now, someone said it earlier, but let's see if someone else can clarify. What's the only other thing I can confirm on this image is congruent to something else? We've already talked about it on example 2 and 3. What else could I say is congruent based on the way the image is made? Yeah.
The line between the two triangles.
The line between the two triangles, correct. And how could I label the line between the two triangles? What would I call that? How could I name that segment? CA or AC, either one works. So I can say that CA, what do I know about CA? CA is congruent to, yeah, it's congruent to itself. What is it? What is the theorem or definition that says that something is congruent to itself? Starts with an R. Reflexive, good. Okay, it's similar to a reflection, but reflexive is the definition that says that something is congruent to itself. Okay, so we have congruent sides. We have congruent angles. And we have another set of congruent sides. R is the angle in between the two sides. If I'm looking at one triangle, is the angle in between the two sides that are congruent? Yes, thank you. So therefore we can prove it by SAS. So therefore we did prove the triangle ABC is congruent to triangle CDA. And my reasoning is just SAS. Yep. Yeah. All right, last question, number 5. Okay, given C is the midpoint of AE and DB, prove that triangle ABC is congruent to EDC. Okay, so as always, our first statement is always whatever our given is. So C is the midpoint of AE and BD, and that is given to us. Okay. Okay, on our image, we have some markings for congruent parts. Why can we say those parts are congruent based on what was given to us? Yep.
It's the midpoint.
Definition of a midpoint. Good. So in order for us to prove it, we need to write it down. So just like anything else, even if it's told to us, we have to write it down some way. So if I said segment AC, what segment is AC congruent to? EC, good. And what about BC? What is BC congruent to? DC, good. Okay, and notice that we have the same order going, okay? So AC is gonna go to CE, so they're going to the same point. Okay, and we said that was because of definition of a midpoint, good. You know where the midpoint is, you know the parts of them are congruent, good. So we already have 2 sets of sides congruent. Okay. If we are to prove that triangle ABC is congruent to EDC, what angle am I wanting to be congruent? What angle needs to be congruent for this to work out for us? And the emails keep coming. What angle do I want to be congruent in order for this to work out with SAS? Look at the image. Look at the problems that we've done. What? So remember, angles have to be 3 letters. Yes.
A, C, B, and D.
A, C, B, and ECD would be correct. Okay, we want these angles on either side of C, going this way, to be congruent. How could we prove that these angles in here, how can I prove that this is congruent to this? What type of angle is created by 2 intersecting lines? Give everyone a second to think. What type of angle is created by 2 intersecting lines? Okay, tell someone near you what you think the type of angles are created by 2 intersecting lines. Okay, what type of angles are formed by two intersecting lines? What type of angles are those? Evelyn? Vertical angles, yeah. And you have two intersecting lines and the being court, just two intersecting lines. Anytime you have two intersecting lines, you will have vertical angles. Okay, therefore, can I prove that I have side angle side? We have a side, an angle, then a side again. Correct, good. So then I have proved that ABC is congruent to angle EDC. Okay, so that is the end of the notes. Like I said, your assignment is a combination of 5.2 and 5.3, and I will tell you in Clever or Canvas what questions require work. Okay, so I'll leave that up there for you to look at, and you can go ahead and I'll get big ideas set up for you guys.